This very video you're watching right now, have you ever stopped to think about how it actually got to you? It's on this incredible invisible journey, traveling thousands of miles from a server somewhere out there, all the way to your screen.
It kind of feels like magic, right? But it's not magic, it's just some seriously fascinating engineering. So what's the secret? How does all this data actually zip across the globe in like a split second? Let's trace its path together.
All right, so to really get how this works, we've got to bust a pretty common myth first. When you picture data flying around the planet, what's the first thing that pops into your head? For a lot of us, it's probably satellites. I mean, it sounds totally logical, doesn't it? A data center just beams the signal up to a satellite, and that satellite beams it right back down to you. Super simple, clean, and, well, completely wrong. Okay, so here's the catch. Most of these communication satellites, they're orbiting way up there, about 22,000 miles above us. So for signal to go from the ground up to space and then all the way back down, we're talking a mind-boggling 44,000-mile round trip. And that huge distance, that creates a serious delay, a lag. We call it latency. Look, even moving at the speed of lights, that 44,000-mile journey would make streaming a video like this or playing an online game just impossible. So if it's not satellites, what in the world are we using that's so much faster? The real answer is, honestly, even cooler. See, the internet isn't floating around in some magical cloud. Nope, it's a massive physical thing, a network of cables running right under our feet and stretched across the deepest ocean floors. So this very explainer you're watching, it started its life on a little solid-state drive, tucked inside a super powerful computer we call a server. That server lives in a gigantic data center. And from there, the video was turned into tiny pulses of light and literally shot through this huge global web of fiber-optic cables. Yeah, these cables, they are the absolute backbone of the internet. I mean, just picture it. There are specialized ships out there right now, carefully laying these cables, made of glass fibers thinner than a human hair, across the pitch-black, crushing depths of the ocean floor, just to connect continents. This physical network is what makes our whole digital world spin. Okay, so we've got this global light-speed highway. But with literally billions of devices online, how does this video know to find your screen and not, say, your neighbor's? Well, it all comes down to having the right address. Every single device connected to the internet, your phone, your laptop, even the server that's holding this video, it gets a unique ID. It's called an IP address. And you can think of it just like a shipping address for your house. It tells the data exactly where to go. But here's the thing. Computers are great with long strings of numbers. We humans, not so much. Could you imagine having to remember like a 12-digit number for YouTube, another for Wikipedia, another for every site you visit? No way. It would be an absolute nightmare. And that's where something called the DNS, or Domain Name System, saves the day. Just think of it like the internet's giant phone book. You know the name you can remember, like youtube.com, and the DNS is the thing that looks up the actual number, the IP address that your computer needs. And this whole lookup happens in like the blink of an eye. You type youtube.com, your browser instantly asks a DNS server, hey, what's the number for this? The server shoots the IP address back and bam, your browser is connected to the right place. It's a super elegant and totally essential system. All right, so we've got the physical highway and we've got the digital address. But what about the data itself? I mean, how does a massive video file like this one get sent all the way across the world without creating a colossal traffic jam? Right. This video file is huge. It's just a giant collection of zeros and ones. Trying to send it all in one single chunk would be like trying to shove a river through a straw. It's slow, it would clog up the whole network, and if just one tiny bit gets lost along the way, the whole file is ruined. Thankfully, the internet is way, way smarter than that. Instead, that big stream of data gets chopped up into thousands of little, easy-to-manage chunks. We call them packets, and each packet is like its own tiny, self-contained envelope. It's got a small piece of the video inside, the to and from IP addresses, and, this is key, a sequence number, so your device knows how to put it all back together in the right order. And here's where the real magic happens. Each one of those packets travels on its own. They can take completely different routes to find the fastest path at any given second. So they might show up all out of order, but who cares? Your device just looks at the sequence number on each one and reassembles the video perfectly. And hey, if a packet gets lost in transit, no big deal. Your device just pings the server and says, hey, can you send packet number 7532 again? It's an incredibly smart, resilient, and efficient system. So after that epic journey across oceans and continents, the packets are on their final sprint, what we call the last mile. That main fiber optic cable hits your neighborhood and connects to either your Wi-Fi router at home or a cell tower nearby. Your router takes those pulses of light and turns them into electrical signals for your Ethernet cable. The cell tower turns them into electromagnetic waves that fly through the air to your phone. And that's it. Your device finally gets the signal and puts all those packets back together into this video.
So there you have it, from a solid-state drive and a data center to pulses of light and an undersea cable, given an address by the DNS, chopped into thousands of tiny packets, all just to be perfectly reassembled on your screen. That is the amazing, invisible journey that happens every single second to make our modern world work. And what's really wild is that this entire global nervous system was built in just a few short decades. It's just an incredible testament to human ingenuity, right? It really makes you stop and wonder, if we've come this far, this fast, what will the internet's next incredible journey look like? And where is it going to take us?